the universe is full of mysteries. Since the dawn of time, we have looked up at the stars and wondered what secrets they hold. In our quest to quench this thirst for knowledge, we have built incredible instruments. Telescopes, massive structures with lenses pointed towards the heavens. Each new telescope brought us closer to the answers we sought. And then came the James Webb Space Telescope, launched on Christmas Day 2021. A marvel of engineering, JWST promised to revolutionize our understanding of the cosmos. It could peer further into space than any telescope before it, seeing the faintest glimmers of light from the universe's infancy. The JWST carried the dreams of countless scientists, engineers, and astronomy enthusiasts. The telescope embarked on its journey to a gravitationally stable point, 1,000,000 miles from Earth. There, it would begin its mission. A mission to observe the universe in unprecedented detail. The world held its breath. The first images arrived, sharper and deeper than we could have imagined. It was then that the whispers began, whispers of something unexpected. Data poured in from the JWST, overwhelming scientists with its sheer volume and complexity. Among the stunning images of distant galaxies and nebulae, there were anomalies, patterns and structures that defied explanation.
Then, a team of researchers at NASA made an astonishing claim. They had detected gravitational distortions. These distortions suggested the presence of another universe.
The scientific community was abuzz. Could the JWST have stumbled upon evidence of a parallel universe? The possibility of other universes, once relegated to the realm of science fiction, was suddenly within the realm of scientific inquiry. Deep within the constellation of Ursa Major, the JWST focused on a seemingly empty patch of sky. This region, known as the Hubble Deep Field, had already revealed thousands of galaxies in previous observations, but the JWST, with its infrared vision, peered even deeper into the cosmic tapestry. Faint, ghostly images emerged from the darkness. These were not simply more galaxies. They were mirror images of galaxies we already knew. It was as though someone had placed a cosmic mirror in the depths of space, reflecting back our own universe. The JWST had captured images of structures that should not exist within the known laws of physics. The anomalies didn't end there. As the JWST continued its observations, more and more forbidden symmetries were discovered.
It was as if our universe was interacting with a mirror image of itself, a parallel universe where the laws of physics were subtly different.
The scientific community grappled with these findings. Some clung to conventional explanations, attributing the anomalies to instrument error or as yet unknown astrophysical phenomena. The debate raged on, fueled by each new discovery from the JWST.
Theoretical physicists began to whisper about the God equation, a hypothetical equation that could unify all the fundamental forces of nature.
Some physicists believed that the God equation, if it existed, would also hold the key to understanding these parallel universes.
These were heady concepts, pushing the boundaries of human comprehension.
The world watched with bated breath as scientists grappled with the implications of these discoveries. The JWST had opened a Pandora's box of cosmic mysteries, forcing us to confront the very nature of reality itself.
Imagine our universe as a vast flat sheet, a cosmic membrane, or brain for short, floating in a higher dimensional space.
The JWST's observations breathed new life into these theoretical discussions.
The idea was both exhilarating and terrifying.
The JWST couldn't answer these questions, but it had opened the door to a realm of possibilities previously confined to the realm of science fiction. Scientists began to explore the implications of brain collisions, speculating that such events could release vast amounts of energy.
Quantum mechanics, the strange and counterintuitive world of the very small, also offered a possible explanation for the JWST's observations. According to quantum theory, empty space is not truly empty.
These quantum fluctuations, as they're called, are normally too small and short-lived to be observed directly.
The JWST's observations could be interpreted as glimpses into these other bubble universes.
The multiverse, once a fringe concept, was now being taken seriously by some of the world's leading physicists. The JWST had inadvertently provided the first tantalizing hints that our universe might be just one of many.
The quest to understand the JWST's observations went beyond just images and light curves. Scientists also turned their attention to gravitational waves, ripples in the fabric of spacetime predicted by Einstein's theory of general relativity.
Gravitational wave detectors such as LIGO and Virgo had already detected numerous such events.
The idea was simple, yet elegant. If a gravitational wave passed through the space between us and a distant galaxy, it would slightly distort the fabric of spacetime.
The implications were profound. Gravitational waves from the early universe could provide insights into the nature of inflation, and perhaps, just perhaps, they could even provide clues about the nature of the multiverse itself.
As the scientific community grappled with these mind-boggling possibilities, a different kind of explanation began to surface.
The idea that our reality is a simulation has been a staple of science fiction for decades.
Proponents of the simulation hypothesis pointed to these anomalies as evidence that our reality was not as it seemed.
While most scientists dismissed these ideas as pure speculation, the fact that they were being discussed at all was a testament to the profound sense of wonder and unease that the JWST's discoveries had unleashed. The telescope had opened a Pandora's box of cosmic mysteries. It was unclear what other strange and unsettling truths might lie within.
As news of the JWST's anomalies spread, a wave of speculation and intrigue swept the globe.
A word on the street was that certain images deemed too disturbing for public consumption were being kept under wraps by NASA.
Internet forums lit up with speculation. What were these forbidden images? Were they evidence of advanced extraterrestrial civilizations?
The lack of official confirmation from NASA only fueled the flames of speculation. The line between scientific curiosity and paranoid conspiracy was blurring.
Among the many rumors swirling around the JWST discoveries, one stood out for its sheer audacity: the Galactic Federation conspiracy.
According to this theory, the JWST wasn't just a telescope, it was a communication device built to establish contact with this Galactic Federation.
Why would an advanced alien civilization choose to communicate with us through faint echoes and gravitational distortions? They claimed that the Galactic Federation was bound by a strict non-interference policy.
As outlandish as it seemed, the Galactic Federation conspiracy resonated with a segment of the population hungry for answers. The idea that we were not alone offered a strange sort of comfort in the face of such profound cosmic uncertainty. The JWST's revelations also breathed new life into a peculiar phenomenon known as the Mandela effect.
Some theorists speculated that the Mandela effect was not simply a case of faulty memory, but evidence of something far stranger.
The JWST's observations, particularly the echoes of familiar galaxies, seem to lend credence to this theory.
The idea of parallel universes and alternate timelines was no longer confined to the realms of science fiction. The JWST had thrust these concepts into the public consciousness, leaving many wondering if we truly understood the nature of reality itself.
The scientific community grappled with a growing mountain of data from the JWST. Anomalies, once dismissed, were becoming difficult to ignore. Echoes, forbidden symmetries, and faint whispers of gravitational waves pointed to something profound.
Renowned scientists debated the implications of JWST's discoveries. Arguments flared. Data was scrutinized, theories proposed and discarded. The weight of evidence was slowly tipping the scales.
The possibility of a multiverse was now being seriously considered. Section 2. Dissenting Voices. As with any revolutionary scientific discovery, the JWST's findings were not met with universal acceptance. A vocal minority of scientists remained skeptical, urging caution and restraint in interpreting the data.
These dissenters, while acknowledging the strangeness of the JWST's observations, argued that more mundane explanations were still possible. Instrument errors, they suggested, could not be ruled out entirely. The JWST, for all its technological marvel, was still a complex machine operating in a harsh and unforgiving environment.
Others pointed to the possibility of unknown astrophysical phenomena, natural processes that we haven't yet discovered or understood. The universe, they argued, is vast and full of surprises. To assume that we have already discovered all of its secrets is arrogant and premature.
These dissenting voices, while often drowned out by the chorus of excitement and speculation, played an important role in the scientific process. They served as a necessary counterbalance, a reminder that extraordinary claims require extraordinary evidence. The burden of proof, they argued, rested firmly on those who claimed to have glimpsed the multiverse.
Section 3. A new cosmic perspective. Regardless of whether the JWST's observations ultimately proved the existence of the multiverse, one thing was certain. Our perspective on the cosmos had been irrevocably altered. We could no longer cling to the comforting notion of a single, unique universe, a cosmic cradle for all of existence.
The JWST had shown us a universe far stranger and more mysterious than we could have ever imagined. A universe where the laws of physics might not be so universal after all, where echoes of other realities might be lurking just beyond our perception.
This new cosmic perspective, while unsettling to some, was a source of immense excitement and wonder for others. It was a reminder that we are still in the early stages of exploring the universe, that countless mysteries remain to be uncovered.
The JWST, once a symbol of our quest to understand the cosmos, had become a portal to the unknown. It had shown us that the universe is not what we thought it was, and that our journey of discovery had only just begun.
In the end, the most profound impact of the JWST's discoveries might not be the answers it provides, but the questions it raises. Questions that strike at the very heart of our existence. Questions that challenge our most fundamental assumptions about the nature of reality.
If our universe is just one of many, are the laws of physics the same in these other universes? Do they have different fundamental constants, different forces of nature? Could life exist in these other realities? And if so, what form might it take?
These questions, once the domain of philosophers and science fiction writers, are now being asked in the hallowed halls of academia. The JWST has shattered the boundaries of our scientific imagination, forcing us to confront the unknowable unknown.
And so we stand at the precipice of a new era of cosmic exploration, an era where the search for extraterrestrial life is intertwined with the search for other universes. The JWST, with its unprecedented view of the cosmos, will continue to guide us on this extraordinary journey, pushing the boundaries of human knowledge and challenging us to redefine our place in the grand tapestry of existence.
The impact of the JWST's discoveries extends far beyond academia, rippling outward, touching every aspect of human endeavor. Philosophers grapple with infinite versions of ourselves, each living unique destinies. Theologians question the nature of creation in a multiverse.
Artists, writers, and filmmakers are inspired by the multiverse, weaving tales of parallel worlds. The line between science fiction and scientific possibility blurs, fueling our imagination.
Even our everyday lives are touched by these discoveries. Our universe might be just one of many, shifting our perspective.
The JWST reflects a species grappling with its place in the grand scheme. We are humble travelers on a tiny planet in a wondrous universe.
The James Webb Space Telescope, a beacon of human curiosity, has opened our eyes to a universe teeming with possibilities.
This is our cosmic inheritance, a gift from generations before us.
The future of space exploration is bright, filled with the promise of new discoveries.
As we stand on the threshold of this new era, let us embrace the unknown with open minds.